Hello and welcome to this next session, and Happy New Year. And I hope you've managed to get a bit of rest over the holidays, or if you haven't had a rest, then at least you might have had a bit of time to catch up on some of the sessions we've covered since the beginning of this course. So we're on session 7 now. So if you've booked in for all of the courses, you should have access to all 6 so far. If you've missed them, as I said, please do email me and I will share them with you again. And if you're having trouble with any of them, please do contact me. I don't want you to feel you haven't got access to that information if you've booked onto the sessions. If you've got a Hub account, really useful to have that, because then I can set up these groups so that you've got a group for each of our sessions and you'll have access to those documents really easily through Hub. I have transferred by WeTransfer, which is what I need to transfer these large documents with, but there is a limited time that you have access to them. So if you don't have a Hub account, then I will just have to send you it with WeTransfer, and I can always send it again if you lose it. So I'm just going to share my screen with you. This PowerPoint, as I said, is going to be available after we've finished. Basically, in the next couple of days, I will send out an email which has got this PowerPoint in it. It'll also have a recording of the session and any resources that I've mentioned. But hopefully the recording is going to be providing you with all the information. But if you have any questions afterwards, then please do feel free to email me. My contact details will be on the sheet as well, on the PowerPoint as well. So this is the session we're doing today. We are looking at outdoor learning in the curriculum for Wales, session 7, practical ideas for going through the numeracy, maths and numeracy AOLE. Okay, so we did science and technology last time, and this is the next one we're going to be working through. Bit of housekeeping. You probably know all this by now, but just to show you, please keep your microphones on mute. And try again. And as I said, I will be recording the session. So if you do not want to be seen, then keep your cameras off, as most of you have. If you have got breakout rooms, which we might have time to do at the end, then if we have breakout rooms, then that will not be recorded. So if you want to put your cameras on, then that's absolutely fine, and you won't be seen by anybody and it won't be recorded. Chat function, you've hopefully been using it already, introducing each other, but if you do want to use that at any time to ask questions, please do. I will try and keep an eye on it. It's quite tricky when I'm showing my screen, but I will keep having a quick look, and I will be stopping every now and again to say, is there any questions, just in case I've missed anything. And also, a bit like the science and technology AOLE webinar that we went through last time, that training, this is not that interactive, I'm afraid. There's a lot of information that I'm going to be giving to you, lots of ideas. That's the whole point. And naturally, usually it would be outside and I'd be showing you these practical ideas, but unfortunately, because we're on Zoom, it's going to be a lot of me talking and me showing you pictures. But I'm hoping if all this Omicron goes away, there may be a point where we might actually be able to have a face-to-face one, at least maybe in South Wales and maybe another one in North Wales, but that's just hopeful thinking at the moment. So there will be less, it'll be quite didactic, I'm afraid, this session, but it means that I've got lots of information that I'll pass on to you, which will hopefully be useful. If we've got time at the end, we're going to do breakout rooms so that you can discuss with other people from other schools what you've heard today, and also what you're doing at the moment in terms of your outdoor learning using maths and numeracy, and ways in which you think you could use the information that I've given you today to increase the amount of outdoor learning you do. Because the whole point of this training course is that so you can take what you want and then reproduce it or recreate it in the image of your school, because of course the new curriculum is all about how your school is actually taking its curriculum and making it unique to your school. So nothing from here can be identical for everybody, because you've all got your own ways of actually promoting and developing the new curriculum. So what I'm going to do is I'm going to go through all of the what matters statements for the maths and numeracy AOLE, and looking at how the progression steps occur through each one. So we're going to be looking at progression step 1, 2, and 3. So progression step 4 is really lower secondary, and there is nobody here that I know of is doing secondary, we're not really going to touch on progression step 4 at all. We're going to stick with progression step 1, 2, and 3. And I know sometimes there's ways of tweaking it in order to make it suitable for progression steps 2 and 1 simultaneously. And if that's a possibility, I'm going to try and identify that for you so that you can see what kind of activities you could undertake, so that if you've got learners who are in different progression steps, you could still undertake the activity, but you can slightly tweak it so that they can collect the data or produce work that's suitable at their range. So we'll try and do that as well with the progression steps. Last session, at the end of the feedback form, I asked what you wanted to cover in maths and numeracy, and a few people answered. And one of the things that was specified was the progression steps and how we do that in terms of mathematics. How do we progress? So I'm going to make sure that I focus on that. The other thing that was identified that you wanted me to cover was reasoning, which is perfect for outdoor learning. So once I've been through all of the requirements of the what matters statements, so we're going to just go through briefly what they mean in terms of the mathematical content, then the majority is going to be focusing on practical ideas to teach those what matters statements and how to differentiate for the progression steps. We're going to go through all 4 of them. Obviously, we've got 1, which is about number, 2, algebra, 3 is geometry, and 4 is statistics. And then at the end, I'm going to go through some reasoning activities. These are quite high level ones. So they are kind of progression step 3. Maybe you might be able to differentiate them to progression step 2. And if I can think of some simpler ones, I'll add those as well. But the reasoning is the best way of using the outdoors is really through this reasoning. As you'll find through this session, using the outdoors as a resource for maths is really that real life mathematical issues that we come up with in life after we've stopped using it in school and doing sums and things like that. So hopefully the reasoning will come out through the rest of the session as well. So hopefully that is what you want to hear today. And we're going to crack on, first of all, with just in case, because I have no idea where you are at this point in your journey for the new curriculum, just identifying an outline of what the maths and numeracy outdoor, what matters statement actually entails. So maths and numeracy has got 4 what matters statements. Each AOLE has got different numbers, so it's got 4. And in all of those and in all the other areas, it's divided into the 5 progression steps. Now, it's not exactly, but the 5 progression steps are: progression step 1 is really meant to reach that point by the end of age 5, so it's kind of nursery and reception. Progression step 2 is a kind of by the age of year 3, so it's kind of key stage 1 as it was. Progression step 3 is by the end of age 11, so it means by the end of primary really, so that's kind of key stage 2. Progression step 4, we're starting to go into lower primary, key stage 3, and then step 5 is GCSE, which of course they haven't written yet, so we can't really talk about that much. So we're not going to be looking at progression step 5 at all. And progression step 4, I may touch on a few things which you might be including in your primary, but we're going to be focusing on progression step 1, 2, and 3. Now, although you've got your 4 what matters statement, and just like in the science and technology AOLE, there's a lot of information in the other parts of the curriculum. So make sure when you're looking at that curriculum, you also look at the key considerations. I've been talking to quite a few teachers recently and head teachers as well. And when I've mentioned about the key considerations and the content that's included in it, they've gone, oh, I haven't looked in there, which is a slight issue, I'm thinking. The maths one, if you look at the key considerations in the maths, there's not, to be honest, a lot of content there that isn't in the what matters statement. So majority of it actually is covered in the what matters statement, but it's a bit more focused and is a bit more detailed in the actual content you need to cover. And this is just the key points in the key considerations that I've got here. And I just want to draw your attention to the ones that are really relevant to outdoor learning. So obviously most of them are what you expect to teach in a mathematics curriculum. But if we look at the ones which are associated with being outside or could be used outside, things like that first-hand experience. So obviously you can do first-hand experiences of doing mathematical concepts and mathematical theories, but also first-hand experience outside of using it in the real world is identified in 2 of these points. So we've got the first-hand experiences point, but we've also got the one that says using real life examples to introduce, explore and consolidate mathematical concepts. So realistically, if you're teaching a mathematical concept inside, if you're going to then make it real, giving them another worksheet or working through another example which just brings in the practicalities of it is not really what I would call real life examples. What I think they should be talking about is actually going outside and finding the maths in the real world. So if you've taught them about percentages, then you need to go outside and see what that actually means and might mean in the future in your life. Are you going to be collecting things and trying to see percentages of something in an abstract way? Probably not. You'll probably be much more concrete, collecting things and sorting them and working out proportions. So we're talking about practical activities, and outside provides an awful lot of resources for that, which we're going to be looking at. We've also got the fact that they're saying about engaging in meaningful and substantial tasks. And again, they specifically say modeling real life numerical problems within that one. And again, real life numerical problems, you've got obviously things like financial, which can still be done inside, although there are some outside that we'll mention. But there's a lot that we can be doing outside, which are things that they might come across in real life. So for example, if you're going to be painting something, if you're going to be building something, if you're going to get quotes for something, that's real life maths that you're going to have, and identifying what you need to actually do in terms of what mathematical concepts you have to undertake to find out what the costing might be to paint something, to build something, to develop something. That's something you need to go outside and actually see the product and the resources available. And then lastly, the last one is all about looking at the 5 mathematical proficiencies, which we'll look at in the next slide, but they're talking about in a range of contexts. And again, in a range of contexts, we could really look at some practical application for that to make it really bringing it to life. But all of these, of course, feed into those 4 purposes, which means it's more meaningful and it's real life learning. So identifying the opportunities for outdoor learning with maths really helps you to focus on those 4 purposes. Unlike the other AOLEs, of course, apart from the literacy one, we also need to consider the literacy and numeracy framework, which is on top of the AOLEs. So it's unfair, it's a bit of a shame that they didn't actually just fully integrate it into the What Matters statements and the new curriculum. But in terms of the difference, or the things we need to also consider in terms of the numeracy framework, these are our 5 mathematical proficiencies. And really, they're almost like ways to be mathematicians, not just what. It's not what you know, how to add up, how to divide. It's how you understand things, how you use maths and the core concepts behind it. But within the numeracy framework, the bits that are really important in terms of outdoor learning is the fact that they say about it can be applied and connected by using a range of real life contexts to introduce and explore mathematical concepts. So they're identifying the fact that these real life contexts, so I take that as being outside in the real world, you can use that to introduce, you can also use it to explore maths concepts that you've done inside. You can also use it to consolidate. And I think all 3 have got their place, but consolidation is key, because if you can be distracted, or students can be distracted when they're outside. When they're inside, you can focus in on the key concept. Once they've understood that and you take them outside, that's when you really get that understanding of whether they get it. And it is very clear when students can actually understand the concept in another context, but also the abstract into a real application when they've literally got to do it physically. And I'll give you some examples of where I've seen that work and where students have struggled with that as we go along. So these are some of the other things. They're talking about drawing on the understanding of the basic structure and applying it to different contexts. So just like in the What Matters, the key considerations there, using appropriate equipment, and that's really useful to do outside, because Inside, you are restricted by scale, the fact that you are in a classroom, you've only got so much room. Outside, we can get to a much bigger scale, which means we have a much wider range of equipment we can use, and a greater amount of resources, natural resources, for things like non-standard measurements, and also problem solving. Problem solving is a fantastic way to consolidate maths and also to bring in cross-curricular as well as cross-topic mathematical concepts, and making sure they have that understanding of where those different aspects of maths fit in together and how they are not discrete from each other. And outside, as I've said before, the outdoors has not got one subject. It is completely cross-curricular naturally. So all the aspects of maths come together outside as well. So we're going to start with what matters statement 1. And again, I have rewritten the curriculum into a spreadsheet so that it's a bit more usable, because I find it on Hub very difficult to start clicking across and scrolling and clicking down and scrolling across. But this is not word for word, because I found that a lot of the information there was a bit too wordy, for one. And there's also, I think, an awful lot of terminology in this AOLE, which can be a bit misleading, but also is a bit unwielding if you're non-specialist. So this has kind of summarized all the aspects in the progression steps. And then in the next slide here, I've just put the key points of what you need to cover in what matters statement 1, so that we can identify what we can use in the outdoors. But what matters statement 1 is all about the number system. So it's the actual strapline is the number systems used to represent and compare relationships between numbers and quantities. And it is the basics. You cannot really start without number systems and understanding number. So really, this is something you will be really embedding in your progression step 1. So in your nursery and your foundation phase. So it's really important to get this undertaken and really embedded in those first few key year groups. What it refers to is exploring that number. So in that progression step 1, they say just to experience and explore number. So that's going to be the form of it, so what the actual shape of it is, but also the meaning of it. What does that actually mean? And it's just getting that understanding of how the numbers are sequenced and what they actually mean in real terms of how, you know, grouping different items, and also thinking about tens and other key concepts. Also recognizing it. So we're looking at understanding what the shapes are, and understanding place value and just that number system. And again, later on when we get to progression step 3, we did looking at things like negative numbers and how numbers behave like that. Really key is the mathematical language that underlies any further understanding of maths. So we can't really move on without having the terminology there. So things like estimating to check your answers, but estimating in terms of measuring. You've got to understand what this term estimating means before you can start to actually practically do it. Things like fractions, understanding what a fraction actually means, but also they need to have practical experience of finding ways in introducing fractions into their teaching, their learning as well, and percentages as well. So all of these new words need to be developed. Counting, looking at sets, forming quantities, so putting things into groups of different amounts. For further progression steps, we've got integral exponents. So we're talking about powers and square roots and things like that. So we've got these weird terminologies, these, again, another bit of language, but it's a specific thing that we only have in the maths AOLE really. Calculating, so that's your classic maths, isn't it? Your numeracy. So using the 4 operations and doing sums for those. Grouping and sharing, so how do we multiply? Creating arrays, so that's so arranging objects by columns or rows to make certain numbers. Ratio, proportion and scale, and then last of all looking at money and applying financial calculations in a problem-solving context. So that's the main content of the What Matters Statement 1. So what I'm going to do now is I'm going to go through those What Matters statements, or the thing behind those, the topics behind those What Matters statements, and give you some practical ideas of how you could teach those to the different progression steps or the different year groups. So we're starting at progression step 1. So we're talking about nursery and reception. We're talking about continuous provision to start with. So within your continuous provision, I'm sure that you can always have some numeracy element to it. There's an awful lot that you need to embed at that age. So loose parts are a really good way of you to introduce things like number, and it is much more concrete than actually a number, the actual image itself. So we're trying to combine the two there. So using the loose parts to actually create the numbers. So like this image in the middle here. So using loose parts to create a 1 or create a 2 and create a 3. And then that just gives them that idea of those shapes of those numbers as well. But also the loose parts are really useful in terms of counting. So we can start to group them. We can start to create sets of them. It also links into the sorting. You can start to do ordering. So thinking about this picture on the right-hand side of the leaves, this is sorting out leaves, because leaves are fantastic for so many things in terms of maths. So we've got a natural variety there, but we've also got natural sorting. So trying to introduce this idea of how we could sort things, and it gives them that tactile imagery of, right, we're going to put that in that group, and then if I count those, that's that number. So it's a very physical activity as well, which really helps. And then you can then increase this looking at less and more. So which pile has got more, which has got less. And that goes for the loose parts as well. So you've got ones which are bigger, ones which are smaller. So using those key terminology, that language as well. Estimating numbers as well. You can use, lots and lots of things in nature which you cannot count very easily to start estimating. You're going to start small with your progression step 1, but even if you had just a pile of leaves or a pile of conchals, pile of acorn, pile of stones, and they could try and estimate numbers, and then if there's a small number, they can then count them out to check how close they were with their estimating. Number order, again, there's some a really useful resource to make. You can buy them, but you can make them. It's just getting some nice flat stones off the beach or off the bottom of the river. Make sure there's no animals still on them. And if you paint numbers on them, especially if you then varnish them or cover them in something so they aren't likely to wash away, or use acrylic, then numbering those stones and putting them in order, and then underneath you could, so if you put a number 1 and then underneath you put 1 flower, and then put a number 2 and then underneath put 2 flowers, they can see the resemblance between the digit and the actual count as well, what the number actually means. Pictures using objects, again, this is something to reinforce this understanding of whether they've got what that number actually means. So it reinforces the counting. So they go and they collect items. So that's Matchbox challenge I've got there, which is a similar thing, but with pictures, you ask them to go and collect 20 objects, and then they make an object or a picture out of those 20 objects. Could be anything at all. And then you start to count to find out if they've got that 20 or whether they've gone a bit too far. Matchbox, you try, it doesn't have to be a matchbox, it could be any small box at all. They're just going to fill as many objects as they can into the matchbox, and then they take them out and then they count them. So again, it helps to reinforce the counting. Also, if you've got wider, so beyond the continuous provision, so maybe in some enhanced provision, if you're taking them out to the wider school grounds, there's lots of hunts that you can go on. Obviously there's number hunts, and you'll find in lots of posters, lots of signs around your school, in your school grounds or inside, that there's numbers everywhere. So just going to find identifying the number itself, and then getting them. So if you're doing 2s, then going on a 2 hunt. And then also looking in nature as well, and see if you can find them in nature. Now, some of them are really easy. There's a lot of 1s around. You see some nice great twigs, which are nice 1s. 2s, 3s, 4s, 5s, a bit more difficult. But if you look carefully enough, you might be able to find them. But it's just getting them to really focus on that one number that you're trying to find. And you can go on a hunt and see if you can find them in order, and see if you can find how high can you get? Can you get all the way up to 9 or even 10? You can also think about collecting as well. An activity I like to do is I say, right, we're going to go on a number hunt. I'm going to give you a paper bag. Everybody's got a paper bag, and I've put the first number inside your paper bag already. and they open their paper bag and they go, there's nothing in my paper bag. And you're like, yes, exactly. That's the first number. You've got 0 in your paper bag. We now need to go and find 1 of something. So they have to find 1 of something, and chances are they'll go and pick up a leaf or a stick or maybe a blade of grass, and they put that in that bag. Then they go and find 2 of something, and they keep going and see how high we can get. And then you get to the point where you get to 9 or 10, and then the children who had 1 blade of grass are suddenly thinking, oh, I should have really left that till 10. So you then think, right, I will go and get 1 of something else. So it gets them to start thinking about the number, and then they lay them out on the yard, and you can identify if they have actually got the right number for each of their different items. So if you say, right, you can't repeat the item, that really helps. And that's a kind of like a scavenger hunt for all of them as well. You can also start using scavenger hunts to try and get them to think about numbers of different types of items. So again, bringing in a bit of the sorting as well. So giving them an adjective. So 3 long items, or 2 spiky items, or 7 soft items. So they go and collect these, and then they can identify what kind of item it is, and then how many they are, and they can write that on the pavement as well, or on the yard with their chalks. Chalks are fantastic for outside for just identifying what their understanding of what they've actually put there. One thing I will say, if you're laying out things on the yard and it's windy, it's incredibly frustrating. So if you've got 20 leaves in a lovely ordered line from smallest to biggest, and suddenly the wind comes and blows them away, it's really frustrating. If you put them on the grass and stick a twig through them as a peg, then they usually stay put, or you can put a stone on top of them as well. So yeah, think about the location you're doing this in, and make sure that you're in a bit of a wind shadow, so the wind will be blocked by a building, and then it won't blow your lovely creations or your words away. Right, moving on to the older progression steps, so progression step 2, probably thinking about some of the sums, and well, although some of this you could do with progression step 1, these are more enhanced activities. They're not really ones that you could probably do with your continuous provision. So a takeaway tournament is you divide your class into small groups, and you place some loose parts or any natural material of one type on the ground. So a whole bunch of acorns, conkers, leaves, sticks, anything at all. Now on the ground, in the middle, between 2 teams, the teams are either side, and then the team takes it in turn, one child takes in turns to take away 1 or 2 of those items. So they have 1 acorn or 2 acorns, and then the other team takes 1 or 2 of the acorns. And the winners are the team that takes away the last acorn or the last acorns. So there's a bit of strategic thinking there as well. And if you've got older age groups, obviously you could make it, if you increase the number of loose parts, you could make it a much more tricky one. So you can say that with you can take away a multiple of one of the numbers you're thinking of, so, or maybe prime numbers only, or something like that. Maths trails are really probably the best thing you can actually generate in terms of a resource for teaching maths in your school grounds. And maths trails provide the opportunity to reinforce every concept that you've done inside or outside as well, because it gives them the opportunity to move around, which is great for them to feel less trapped, but also gives them a bit of that movement as well. You can be a bit of a race, and where they get to their location, you could do anything mathematical. So it could just be that you put a sum at that location and they have to undertake that sum. Now that's like the basic maths trail. The better maths trails are the bespoke ones that you create for your school grounds. And the best way to do this is to try and get the older students to make a bespoke one for the younger students. So they have to think about the maths that they want to write, the problem solving. They also have to come up with the answer as well. So if I give you a few ideas of what kind of things I've done in maths trails, because I've done them all over, not just in school grounds, around city centres and everything, and they're fantastic. And I've put loads of these examples on the Padlet. So there's some great ones on the Padlet that say what you could do, but you cannot just take that and put it in your school grounds, because your school grounds may not have what they've got. So you do have to make this unique to your school grounds. So you might be saying things like estimate the number of stairs going down into the yard and then count them. So before they go out, they estimate it and then they run and then they count it. You could have it so that when you get to a certain location, which has got the problem or the challenge or the question, that the answer to that one will either give them something to write down or something to do, or also give them the location to the next one. So I love ones that you have created a map of your school grounds, which have got grid references on. And when they get to a location, the question is, say there's a sum, and the second letter or the second number in the sum gives you one of the coordinates to get to your next location. So you don't know where to go next. And it is quite tricky to set up, but once you've got the hang of it, you can really start to, use everything you've got in your school grounds to get them to test their understanding of all concepts. So fence panels, how many fence panels do we have to put here to replace the fence? Or if we want to extend the fence so that it goes around the other two sides of this yard, how many fence panels do we need? So that gets them problem solving, it gets them looking, gets them measuring, and it brings in a lot of those skills. And again, those cross-topic skills within the numeracy and within the maths. How far is it? So distances. So we could do estimating. How far is it to the nursery gate? How far is it to the yard? How far is it to the shop? They're not going to go there, but they can estimate. And again, they can think about strategies. So you're testing their understanding, but also their strategies that they're using. And of course, in maths and numeracy, we're giving them as many strategies as they possibly can have. And it's interesting to know which one they actually draw on when they're given a problem in a different context. Also, if you've got benches outside, a really great one is how many students can sit on the benches in your yard, or can you seat your whole class in the benches? Now, you can also put in a bit of a caveat here and say only one person is allowed to sit on a bench at a time for you to work out the answer to this question. So otherwise you'll get 10 of them sitting down, 10 sit on that bench. Whereas if you only have one, then I have to work out how many people can sit on that bench when only one of them is allowed to sit on it. Same for things like how many students can stand in the football goal, but you're not allowed to go out with more than 2 people. So you've got to work it out from that. And then there are lots of other things you can count. So things like how many windows, how many outdoor lights, how many bricks. But I really recommend you don't have an awful lot of counting activities on your maths trail, because there's nothing worse than just having kids watching, counting bricks. What are they going to learn from that? Unless they're in progression step 1 where you want to improve their counting skills, better to say, right, estimate how many bricks there are in the wall. And so they're using their estimating skills, not just counting a load of bricks or little grass. And also you can bring in other ways of bringing in multiplication. For example, how many windscreen wipers are there in the car park? And so you've got how many, you're going to have to multiply it by 2. Then you can bring in things like percentages. So in the car park, if only 25% of the headlights are working, or headlights and rear lights aren't working, how many bulbs do you need to buy to fix all of the cars? So again, practical ideas, but bringing in the maths they've done inside. But maths trails, really, really recommend them. Bigger and smaller hunts, again, for progression step 1, really. So we're looking at mathematical language and we're looking at size and scale, but we're also looking at estimation as well. And now you can do this as a challenge. So if you put a whole load of questions or a whole load of statements in a bucket, and then learners pick out one of them, and then either the staff reads it and then they have to go and find the answers or go and do the challenge. For example, it could be hug something that's bigger than you, or find a tree that is shorter than you, or sit on something that's very, very big, or run to something that is bigger than a tree, or puts 3 things in a row, or stand next to something that's the same size as you. It's endless, the number of things that you can do for a smaller or a bigger hunt. And you can use whatever is in your school grounds. Number lines. Really good for progression step 2 or 3 when we're looking at negative numbers, because again, really abstract concept, this negative numbers. And if you lay out a number line, then you can kind of get that negative concept. But what's really more useful is using negative numbers in the way in which you would use them in real life. And one of the best ways of doing that is using thermometers. So if you're going out in the winter and you've got a thermometer that goes to the minus, then you get that understanding of why they bothered having negative numbers, why they didn't just start lower down, which is what I always wondered. So using thermometers, you can then identify that. But if you've got a number line and you're drawing that on the yard, then you can start to plot this temperature over the days and you can see how it changes. So is it going up and is it going down? And if so, how much? And also you can do some calculating some sums as well, using this physicality and using different methods. So the number line is a really useful thing to have anyway in your yard. Another idea of using in your yard is having a double-ended hopscotch. So I tried desperately to find a picture of a double-ended hopscotch online. I couldn't find one anyway. But what I mean is a hopscotch, a normal one on one side, and then on opposite it on the other side, one is positive numbers and one is negative numbers. So again, you start throwing a dice or you do sums and you start to move up the hopscotch as you normally would if you use it just for maths. And then when you get to the negative numbers, you've got, you know, that added complication as well. So it's another physical way of doing some mathematical sums. Line up whole height differences as well. So again, if you've got areas in your school grounds which are higher than others or lower than others, that's another good way of looking at negative numbers. So if you think of the main ground level as being 0, you go up, that's going to be positive numbers. If you go down into dips or down hills, that's going to be negative numbers. So again, you can start to get that practical application of why we might use it. So sea level is going to be 0. So below sea level is going to be minus numbers, and above sea level up to mountains, we're going to go up as well, and positive numbers. So it relates to contour lines as well. But again, it gives you that opportunity to show why you might have these negative numbers in real life. So lining up activities, it's a form of sorting, but again, using the materials and resources found in your school grounds. A great one is looking at rocks. So trying to grade them and sort them into the hardest and the softest. And the way you do that, you can just have a nail or you can even use a pencil, rub it on the rock. And if that rock is rubbed by the nail, then the nail is obviously going to be harder and the rock is softer. Then you start rubbing that rock against another rock, and whichever rubs is the softer one, which other doesn't is not. But getting them to come up with ways of doing it and then sorting them, because it kind of identifies the problems with qualitative data as well, the fact that and categorical data as well. So qualitative data is data without numbers, and categorical data is how you sort things into, like, bird types. You can't put them in order. So when you're collecting data and you're presenting data, if you've got categories, trying to understand which goes where on a graph, for example, it's very difficult if you've got these categories. So it kind of brings to life those problems that you might have in trying to graph data if you're using categorical data. You can also do lineup activities, things like colors. So for that also identifies that, colors of the rainbow. And then you've got the obvious lining up, size order. So getting them to line up in size order, getting them to line up sticks in size order, in length order, width order, identifying if there's any relationships or correlations. A great one is to get them to line up in age order and then line up in height order and see how much moving went on. And if not a lot, then you could see there is a correlation between height order and age order. If a lot of movement went along, we can see there isn't a correlation as well. So again, it brings in some of that data collection that we're doing in What Matters Statement 4. Also, the vegetable patch. Just like maths trails, vegetable patch is one of the best places where you can teach maths. There's so many numbers on the back of a seed packet. And even if you're just looking at them and finding the numbers, it helps you to teach so many concepts. When we get on to doing the fractions and the measuring, I'll tell you more about vegetable plant planting. But obviously you've got the seeds there, you've got to count them out. It's a physical thing. And also we're thinking about spacing, and it is just a really practical way of using your number system. Right, so scale. So if you're thinking about teaching scale, then again, loose parts, brilliant, because we have such a range of scale in loose parts. So creating a simple picture like this one in the middle with the squares, using twigs. Twigs are brilliant for just doing really simple pictures. So we've got squares there, and then you just want to make it on a bigger scale. So you want to increase the scale, or your partner increases the scale. Now for the progression steps 1 or 2, you might be saying, right, just make it bigger and then make it bigger. When we talk about progression step 2 and 3, or especially 3, we can say how much bigger. So we're talking about proportions as well. So we can make it double the size. We can make it half the size. We can make it 4 times the size. So you're looking at scale and seeing how physically a scale increases. This leads really nicely also onto mapping activities. So if you've got a map of your school grounds, which is, again, a really great resource because it's got lots of maths on it, you can use your map of your school grounds, and you don't even need to make a very good map. It can just be a photo from Google Earth. So if you can use that, to work out the scale of your map in real life with regards to the multiplication and reasoning. So for example, if you can possibly, for like a easy version of your map, make your map where the school is 10 times the size than it is on the map, then your maths for looking at that would be fantastic. However, you could then also increase the difficulty by having maps at different scales, so it isn't 10 times, so it's much more obscure or much more difficult multiplications. You can also start to use that map and think about proportions. So what's the proportion of grass to tarmac on your school grounds? And you can do it in real life, or you can do it on the map, or you can do both. So is there 3 times more grass than tarmac? So basically maps provide you with so much opportunity for doing, looking at proportion, looking at ratio, and later we'll look at them, of course, because they're brilliant for doing measuring as well. Creating array diagrams like this one on the right here. Again, loose parts, fantastic to represent multiplication relationships. So again, that understanding of what 3 times 3 actually means, or 3 times 5, and doing that physically on an array. It's great to use those loose parts, especially got round ones like stones, for doing that as well. But multiplying outside, you can do that with natural materials. And I love doing this because especially leaves come in lots of multiples. So you can start to test their understanding of multiplication of the number that you're doing, but also you can identify plants, mainly plants, whose leaves come in that multiplication number. So if you look at the pictures on the top here, we've got Scots pine, and pine needles in Scots pine come in pairs. So that's your 2 times table. So lay them out and then write your 2 times table underneath. Next to it, these are buttercup leaves. These come in 3s, or you can use clover leaves. These come in 3 leaflets, and then you've got your 3 times table. Then you've 4 difficult, not so many. You've also got things like horse chestnut, that's got 5 leaflets, but also sycamore's got 5 points. That could be your 5 times table. When you get beyond 5, you start to move on to the animals. So you start measuring or counting in legs. So you've got insects, so if you've got ants, so you're counting in 6s, or you've got spiders, you're counting in 8s, then you can get some woodlouse and you're counting in 12. And then if you're really mean, you can get some millipedes and some centipedes, and you can get them to start counting in those numbers. They are not 100 and a million. They're usually about 52. But again, it gives them ideas of this multiplying. So I love using the natural materials to do the multiplication. Next one, we got some dividing. So we've done multiplication, now we're going to divide. So divide and conquer game. This is something that you could link to a topic. So we're having a wide open space outside, putting hoops out. So the hoops, and the learners have to make equal groups inside the hoops. So you give them a number and they have to make equal groups inside the hoop. And then you look and you'll probably have a remainder, and then they have to discuss what to do with the remainder. And then you start to change the criteria. So you remove one of the hoops, or you can do it in any way you like. So these could be islands and you're doing pirates. It could be anything at all, but it's really useful if you do it with a whiteboard in front of you and you write the numbers, the number of hoops and the number of children on the whiteboard, and then write the sum so they can see the application of the sum. So you've got the sum there, they do the dividing by the children, and then we write the remainder down as well. So they can see the sum and associate that with the application of what they've actually been doing. So it's a really useful one to bring that theory into practice. Doubling game. So again, if you've got, there's some really easy resources you can get hold of. At the bottom here, I've got a 10 square. So this is just a piece of material which has got 10 boxes on it. You can now get egg boxes in 10s, which is really useful, but or you can get trays, you can buy trays with 10. Anything with 10s is really good for any aspect of place value. So we can use it for doubling up. So they place one item in the first box, and then they have to put a double of that in the next box, and then double of that in the next box, and double of that in the next box. And it's great for doing the 2 times table. And then you can make it even more difficult by introducing other factors. So collect 8 items and fill the items with the factors of 8. So again, depending on the progression step, you make it more or less complicated. Math scavenger hunts. Again, we've said about collecting numbers, but also if you give them an egg box or you give them a grid and you give them objects they need to find, and then each object has a score associated with it, then they choose which objects they want to collect, because if the time frame, they haven't got enough time to collect them all. And then at the end, they add up the score to see what they've got. And then they can work out whether, it's worthwhile to go for the 6, which is really hard to find, or whether to get the 1, which is really easy. And they can try and, it's a bit strategic as well. And then we've got money. As I said before, Veg Patch is brilliant for teaching maths. Whenever you get a pack of seeds, usually get, say you've got carrot seeds, you'll have 200 or more carrot seeds. Chances are you will not have space to plant 200 carrot seeds, but 200 carrot seeds will cost you $2.99 probably. You then need to work out how many you plant in the space that you've got. You then add fertilizer, which is going to be another cost. And then at the end, you weigh your carrots. You then work out how many kilograms of carrots you've actually grown. You can work out how much that will cost in a supermarket or in Aldi. And then you price up your profit against how much you paid in the first place. So from that, you've got a bit of a enterprise there that you can work out which is the best vegetable to grow to get the maximum profit, and whether you should actually grow 2. So maybe potatoes underneath or one side, and then at the other end plant something on the top, a salad crop above it. So it's a bit of enterprise there, but the Veg Patch provides a lot of opportunity to calculate real life money situations, something that you could actually get them to buy the seeds, buy the fertilizer, sell the carrots to the parents, and then they can literally see the money they put in and the money they got out and see the profit. Right, fractions. There's a lot in What Matters Statement 1. We are still in What Matters Statement 1. So fractions, fraction walls are really good. So this picture here in the middle of the sticks, this is a fraction wall. So you start with a stick of a known size. So probably 1 meter. You can use a 1 meter ruler. You can cut a stick to size. You need to have at least one, which is exactly right. You can even buy sticks which are cut to size if you really want to, and you place that at the top of your fraction wall, and then the learners have to get 2 sticks to make up to 100 centimeters, so 1 meter. So they need a fraction, they need 2 halves, So they need two 50-centimeter sticks, so they can either break a stick into two, or they can go and find two that are 50. And then you go down, and then you get down the wall and you go to 4 25-centimeter sticks, then 10 10-centimeter sticks, and you end up, oh, come back, and you end up with a wall of those fractions for those sticks. Now I've got a whole set of sticks that I have made and cut to size so they do fit, because of course you can see this picture, it's not perfect, and the sticks have to touch each other. You can't have gaps between them, because then that's not part of the stick. So, but it's a good, gives them a really good understanding of what a fraction actually means, and how 1 is 10 tenths, but is also 4 quarters and also 2 halves. And if you want to be, you know, you can do every single fraction you can think of, and it's a really good way, I think, of visualizing all those fractions being of the same value. Also, leaves provide a great resource for actually producing fraction as well, especially in autumn time. So if you've got a group of leaves, so on the bottom right here's a whole load you could do with fractions. So if you've got a whole pile of leaves in the school grounds, and then you can estimate the proportion of different colored leaves. So if you've got, in autumn time, you've got some reds, some yellows and greens, then they can say what the fraction of red leaves or the fraction of green leaves. You can also use that to create graphs. So we can do pie charts to do proportion. You can also use individual leaves as well, and looking at the proportion of those, or the fraction of those that has changed, because lots of leaves do actually change with literally like a part of it growing. It's not like it goes out from the outside. So if you can find some that you can see some obvious fractions of them which are different colors, those are really nice resources to see. And then you can go big as well. You can think of the fraction of the tree that's lost its leaves, or the fraction of the tree that is red, or the fraction of the tree that is a different color. Frivolous fractions, this is bringing in any kind of fraction concept, so any calculation of fractions, but doing it practically outside. So you give them things like measuring jugs, rulers, meter rulers, any measuring equipment they need, and also things like bean bags and stuff, and you throw them about, and then you just give them a challenge. So collect half of 20 stones. So they have to find 10 stones, 50% of 10 fallen leaves, or take 0.5 of the 14 bean bags, or pick 25% of 12 blades of grass. And if you do this as races, then it's great, because they've got to think quickly and they've got to go and find the items. So that's why it's frivolous. Matchbox fractions, we've said before about picking up filling matchboxes, but again, if you collect the items and then once you've got them, you can then calculate the fractional proportion of each item. So how many stones compared to how much grass. So out of the whole total, what is the fraction of grass that you've put inside your matchbox? Just like you do in class as well, this picture on the top right, you can shade in fractions. So usually on a piece of paper, you've got a rectangle or a square and you're shading half of it. You can also do that with leaves. So you make a rectangle, you make a shape, and then you can cover half of it in leaves, and then a quarter of it in stones, and then leave a quarter of it grass. So you can use that to show different ways of shading as well. And so another practical way of looking at fractions. A scavenger hunt for fractions as well. So again, looking at a bit like measuring, but we're looking at it associated with fractions. So find a leaf which is half its width, or find a stone that is quarter its length. So, or collect 2/3 of a yellow leaf. So again, it's introducing that concept of fractions, but they have to go and find them. Then we've got our 10 frames. This one here at the middle is a box. It's a frame which has got little places to hold on to items. And again, that's really great because that 10 is a whole. So that at the moment is 10 tenths. So that is a whole. So we could then just put 1 in it, and that would be 1/10. And then we could use a rock and say, right, that's 1/10, or that's 0.1. And then you can start to do fractions within that as well. And then the last one here is, again, back to our veg patch, planting. Oh, I haven't put it down there. Oh, so planting in the veg patch. So again, fractions. So half of the bed is going to be filled with carrots, half of it is going, a third of it is going to be tomatoes, and then you can start to use the fractions to do that as well. Right, so that is What Matters statement 1 on number. Does anybody have any questions? I'm just going to look through the chat in a sec. No, if you do want to say anything, feel free to take your microphone off mute or to put it in the chat. Hopefully those are some useful ideas for teaching number. Sorry, I'm just going to pour myself a cup of tea. And we're going to go next on to What Matters statement 2, which is algebra. So not quite as much content in there. And it's not, you can teach things about algebra outdoors, but there's not as much of a range of things to teach in terms of algebra because the content is not as big. Right, so if you're all happy with that, we'll move on to question step 2. So algebra, using symbol systems to express the structure of mathematical relationships. And again, this is the simplified spreadsheet that I've created from the curriculum. And again, we've got lots of terminology here, which if you're a non-specialist can be a bit terrifying. So I've summarized it here in what it actually consists of. So in progression step 1, we're talking about repeating patterns. This is the start of algebra. This is getting people to recognize, you know, that we can put things into some kind of order and then we can change that order. The basis of algebra, we need to understand what the actual equal signs means and what equal means and non-equal. Then an awful lot is all about the algebraic laws, I call them the algebraic laws. There's lots of words in there, but we're thinking about things like A plus B equals B plus A. So all of these laws, these algebraic laws, I used to call them BODMAS. I'm not sure if that's the term we still use, but really all of this, the understanding the key behind how to make sure your equations are making sense and you're following the laws. And then going back to the basics, really number bonds and finding missing numbers are key to algebra. And of course, the be all and end all, the end thing is solving the equations. So how do we teach algebra outdoors? So there's a repeating pattern. There is so much, again, in terms of loose parts that you can use outside and create repeating patterns, and younger children love doing this. And it's a great way of getting them to understand variety and sorting, but also the start of this algebra. So this could be part of a continuous provision, or it could be an enhanced provision, or it could be in the older age groups when they need some reinforcement as well. So organizing objects into repeating patterns. So somebody does that in a pair, and then somebody else copies your pattern, and then they can add some more objects to it, and then see if you can copy somebody else's. And so it just brings this repeating pattern into a longer system. And there's so many objects outside that you can use for that. It's really useful. Also, when you're doing algebra outside, you can use those loose parts to actually represent the numbers in the equation. So using natural materials. So on the right here, we've got pine cones, we've got stones. And I think this provides a non-judgmental way of doing algebra, because there never is any crossing out. So I love the fact that when you're outside and you're doing sums like this, you're moving things around, and so you don't feel that it's written on the page, so you know it's all down there and I can see where I've got it wrong, especially if you're manipulating equations. So if you've got numbers down as objects and you move them from one side of the equals to the other, you've got to embed that idea that you've got to put, you know, change the location, so you're changing the sign as well, and physically moving it from one side to the other, and kind of like, right, it's a positive, it's now a negative, reinforces that by actually putting that physicality there. And so using natural materials for your missing numbers is a great way of reinforcing that. Along with that, you've got magic number squares. So this on the bottom right-hand corner. So magic number squares, of course, just to remind you, is a grid in which every row and column and diagonal adds up to the same number, that magic number. And this really helps to consolidate these number bonds, but it's also a great way of problem solving. And also finding all the range of natural materials in the grounds is brilliant to try and reinforce the fact that maths is in everything. So you can use everything to actually count with. It doesn't have to be actual numbers. Maths also, especially with algebra and a bit of coordinates as well, you can use it to create mazes. The maths of mazes is actually incredibly technical, but there is a great resource if you've got the outdoor learning cards by the OEAP, the original ones. Their team building 9 has got an activity called Amazing Maze. Now, it's not specifically focusing on maths, but in fact it is an algebraic formula that you're actually creating here, even though you don't realize it. So what you need is a grid on the ground, and one group or one person sorts a route out. So they choose which are the squares which will provide the safe route across. And then somebody else from another team has to try and get across. And when they go wrong, they're told they're wrong. They have to try it again, and they have to try and decipher where the squares are. And again, it's a trying to that trial and error, but also it's giving them that idea of there's certain sequences that have to be taken place in the right order for things to take place. This also leads really well into coding as well. So you can expand on that to get into the coding system. Right, that's it for algebra. So does anyone have any questions on algebra? Or any ideas? If you've got suggestions for teaching anything or anything you've done, you're very welcome to share them. Okay, right. Now we're going to get on to the last 2 what matters statements. And I think these 2 are the best ones for teaching outdoors, and in fact provide a huge amount of opportunities, especially with the what matters statement 4. But geometry. So what matters statement 3, the geometry aspect of the area of learning is focusing on relationships involving shape. So we're looking at space, position. We're also looking at measurement and quantifying phenomenon in the physical world. So that's the strap line here. And again, this is a simplified version, but what we're actually covering is time, which I don't know is geometry, but I think they need to put it somewhere. Measuring, so we've got in measuring non-standard units, but also in standard units. And then for progression step 2 and 3, we've got things like length, capacity, mass, temperature. We've got estimating as well. We've got the measurement of those really important parameters of perimeter, area, and then we've got shape, 2D, 3D, their properties. We're looking at reflective symmetry. And when we get to progression step 3, we're looking at nets as well of the 3D property of 3D shapes. We've got angles, and then we've got describing position. So all of those can be taught outside, really. Some of them really, really well with the outdoors. So starting with measuring. So again, we're talking about getting bigger and smaller. So sorting things by length. So progression step 1, we're focusing on now. So sorting sticks by length. And then you can thinking about which one's bigger than your hand. And so using those non-standard units to identify ones that are bigger or smaller than each other, and also comparing them to each other as well. Measuring with loose parts. So if you give them a challenge to make a meter, so they've got a meter ruler, so they've got to make a meter out of loose parts. So you can use pine cones, you could use leaves, you could use twigs, but they have to make it exactly a meter. So how many leaves long is it? You could then also ask them things like how many leaves long is their leg? And it's really important to question them on all of these in foundation phase. Questioning is key to moving them along. But it's really important to get them to start questioning these standard units and non-standard units. So to get them to understand this concept of measuring, if you ask them things like, well, when we lay our arms out and we measure how many leaves it is, I can get 12 leaves down this arm and we can get 20 down this arm. So why is there a different number? Does it matter if we've got the same leaf? Does it matter if it's a small leaf or a big leaf? Does it matter if it's the leaves round the right way? So they're trying to justify the introduction of standard units. That's what a lot of these non-standard identification concepts are. So getting them to identify that for themselves. So that's all about the questioning. And then with estimating larger distances, so things like the length of the playground, the size of the field, and then measuring it, not necessarily with a meter ruler or even a trundle wheel or a tape measure, but things like pacing it. So something that is going to be with them that they can use to measure. So how many paces is it? And then comparing that to other people. So, and then looking at the length of their leg. Also thinking about things that they can't measure. So the height of buildings or the heights of trees. So estimating up is quite a tricky thing to do. But again, if you can get them to look at how big the teacher is or a number of person in their class, and they stand underneath the tall item or the tall building, then they can try and see how many of that person will make the size of the building. So giving them these strategies of measuring the height without having to use any actual measurements or any pieces of equipment at all. Trees are also a fantastic resource for teaching measurement, especially at every age group, because you can differentiate them. And in fact, there is a great resource which is on the Padlet, which was written by NRW, Natural Resources Wales, which goes through teaching maths through trees with progression. And at the very end, I'll show you the progression model that they've got there. But you're starting with the basics of measuring trees, and then you can go on to trigonometry when you get really high up. So the trees provide a huge resource of teaching so many mathematical concepts, especially in the geometry, what matters statement. So if you're thinking about children at nursery and reception, if you want to get them to find a tree their age, I love doing that because they're always putting their hand above their head, if you can see me, and doing this next to trees, because that's what they think, you know, a tree my age would be this height. So obviously they probably won't find one that height, but it's trying to get that concept that trees grow up taller, but they go wide as well. And then identifying again the other ways to measure trees, because we can't reach the top, so we can't measure how high it is. Maybe we could measure another thing. So to find a tree that you can hug, so one that's 2 arms in circumference or diameter, and then find with a partner one that is 4 arms in diameter, so one that you can hug with a friend or with a partner. And although this theme seems well, why do we want to measure in arms? In fact, ancient trees are actually measured in arms. So it is still a method, a non-standard unit, which is used to measure ancient trees. So, you know, it's very feasible that they're using this, and they still might be using it when they've learned how to use it with a tape measure. But again, it's giving them that concept of what we can measure. And when we start to get into the other progression steps, we're still going to be measuring things like round the trees, but of course we want to get a number from it. So they've got the problem solving of, well, we're measuring round, but my ruler is straight. And this is where you bring in this problem solving aspects, and you're providing them the opportunity to choose the right piece of equipment. So if you're asking them to measure the size of trees and you're laying down a meter ruler and a piece of string, then I've seen students literally try and measure round a tree with a ruler, and it's quite hilarious, really. But it gives them, there's a lot of problem solving, but they've got to understand the concept that length, or that you're measuring, is a line and is straight in terms of what the equipment we've got, but in fact it is actually can be in any shape whatsoever. So how do we relate those 2 areas, that circumference to a straight line length? And that's a physical thing that they would have to do. And then looking at water. So playing with water is a great way of identifying volume and the kind of like the factors behind volume. So lots of different containers with different shapes, different volumes. So tall and also broad containers pouring from one to another. And again, the key is all in the questioning. So the TAs or the teachers that are out there saying, whoa, that one looks taller, so that one's shorter, so why does that one hold less than that one? Look, if I pour that in there, it only goes up to there, but that one's really tall. So which one's got most water in it? So it's that asking questions about bigger, smaller, and, you know, again, problem solving. How do we get all of that into all of the tall one into the short one, or all of the short one into the tall one, or how much bigger is that? So it's all about the questioning to push the learners along. Okay, moving now into progression step 2 and 3. Again, maths trails, I've said, but bringing in that measuring aspect. So you're sending them on a maths trail, but you're getting them to measure things as they go. And one really useful measurement for them to identify is something called pacing. So pacing, in terms of a measurement, what you do, and we use this in orienteering and in lots of map work, you lay out 100 meters, or you work out where 100 meters are in your school grounds in a straight line on a flat surface if possible. And you get the students to walk from one end to the other of the 100 meters. And they count their paces, and you count one leg only. So you count that, and that number is your pace. So my pace is 83. And every time I walk 83 paces, I know I have traveled 100 meters. So you can send them on a maths trail without actually giving them any equipment and ask them what's the distance between certain things. They have to pace it out, and then they have to convert that into hundreds. So that's a really good way, because it's going to be an odd number. So they're going to be doing some good maths, good mental maths as they're going along. Also, when you go doing a measuring maths trail, obviously you can measure anything, and you can get them to choose the right equipment. So measure circumference of trees, giving them equipment, they choose which is the most appropriate piece of equipment. So there's so much there. You've also got measuring circumference around bicycle wheels. So there's so many possibilities around your school. I'm sure you can think of loads there. Mapping your school grounds, again, actually creating the map that you'll then use for many other activities. You can then measure the perimeter of things, you can measure the area of things, and that can go onto your map to make sure your map is accurate and to scale. But you can also use it to calculate the difference between certain things, like the proportion. You need to be able to calculate the area to do the proportion. So using your school grounds provides you with that blank canvas to do some measuring in real life. Now I'll just tell you about a school that I was working with, where we were doing a research project on maths, and we had two groups. We had one that was taught inside and one that I taught outside, and the teacher was team teaching with me and observing. And we were trying to discover whether the outdoor students or the indoor students got the concept better, or whether they had a better understanding. It was a concept that they'd been taught already, so it was just consolidation, but it was understanding the problem solving aspect of a mathematical concept. So the one that I'll tell you about was, we were doing area. So they'd been taught area, it'd been they'd gone back over it in class. And then I had the class that are outside, and all they had to do was measure the area of the yard, which I thought would be really easy. I had all this equipment laid out, trundle wheels, tape measures, meter rulers, and they had to measure the yard. We had students that were struggling with maths. We had students who were amazing at maths. You give them a row of sums and they do them without thinking. They were brilliant mathematicians. The brilliant mathematician would come out, and I told them, just measure, what we want is to know the area of the schoolyard. And she just looked at me and went, where's the sum? Where's the piece of paper? Where's the worksheet? Where's the, she was brilliant at maths, but she had no idea how to calculate the area of something in real life. And by the end of the sessions, when we've done them a few, she kind of got the idea, but it just showed that she may be able to do trigonometry, and she could at year 6. She could not actually calculate the area of a yard because she didn't have that practical application. So it just shows that if you don't have that concrete with that practical together, then your mathematician is only as good as doing sums. Is not actually a practical mathematician, and they're not lifelong learners. They're actually maths lesson learners, which is not that useful unless you're going to be a maths teacher, really. So, and also perimeter, they were kept thinking we wanted them to measure the area of the roundhouse there. So we were trying to push them a bit. The roundhouse was a octagon, and of course they had no formula for measuring the octagon, so they had to identify the shape within the octagon to measure it. And they all were measuring the perimeter of it because they really just thought, yeah, I've got a ruler or I've got a tape measure, it will go round it, I'll measure that. And they couldn't work out what to do with that number. So it was really interesting to see the impact and how practical maths is really vital for them to understand these key concepts. There's only so many times you can go around the outside of your ruler or the outside of something inside without making it on a bigger scale outside. Things like trundle wheels as well, great things for using outside, but when we introduced the trundle wheel, they didn't quite get the concept. So they didn't understand the roundness to the length. So they just walked around and it was clicking, and they didn't actually understand that when they go round, that round is actually 1 meter long. So using trundle wheels gets you to identify the fact that you can use that circumference as a measurement of length as well. Because we did another investigation looking at bicycles, and we saw the challenge was, how many times does the wheel rotate when you travel 100 meters? And again, they were literally following their bike and watching the wheel go round and trying to count as it went. Not until the very end did anybody think about measuring the bike and then calculating from the bike. They all were trying to cycle it. So again, giving them these opportunities to use different materials and different resources and different environments brings out so many more problems, but also so much more understanding and such a better understanding of the concepts you're trying to relate to them. Measuring the area, again, of regular and irregular shapes. As I said, we had a roundhouse, trying to get that, I know that's a regular shape, but trying to get them to understand that it's made out of triangles, and so you know how to calculate the area of a triangle, and we just multiply that by it. Literally, that was half a day trying to get them to work out that concept and trying to see the shapes within it. And this is the sort of thing that they would probably be actually doing in real life. So irregular shapes. So measuring the area of the yard, great, easy. It's a rectangle. I know the formula for that. But then you've probably got bits of your yard which suddenly go narrow and then go big again. So trying to work out how are we going to do that? So trying to find the shapes within the irregular shape. So that's a rectangle, I know how to do that. Oh, I could put another rectangle here, I know how to do that. I could put another rectangle there. So actually doing it physically in space, or using a map and trying to work out where the shapes are on the maps. Maps are great for finding shapes, and then you can go and do the calculations as well. Measuring trees. So much going on in terms of measuring trees, as I said, and there's a great resource I've put on there, but relating it to angles as well. If you want to measure the height of the tree, there's 4 different ways of doing it really, and I have got a video of how to do it, but it's all on that resource for Natural Resources Wales. But if you'd like a copy of the video, if you want to send me an email, I can send you that. I can't put it on YouTube because I did it for an organization, but if you want that information on how to measure trees in a practical way, but you can look at angles by standing away from the tree and looking up at it at a 45-degree angle. And if you think about your trigonometry, 45-degree angle between the trunk and the ground is a kind of nearly perfect 90-degree angle. So the distance between where you're standing and the bottom of the tree is the exact same as the bottom of the tree and the top of the tree. And the way you look at a tree at 45 degrees is you just look between your legs until you can see it. Or you can use a kilometer, or you can get a ruler and hold that until the ruler is the same size as the tree. Get someone to stand at the bottom of the tree, turn your ruler by 90 degrees so that it's horizontal, and then get somebody to walk to the end of the ruler, not literally, but in visual, and then that distance is also the same as the height of the tree. Circumference, measuring the tree circumference, but also relating that to their age. Some nice little bit of maths there, so you can just multiply it by 2.5 and you'll get the age of the tree for the average tree. but it gives them a bit of maths, but it also gets them to start thinking about growth rates, and you're talking about cross-curricular as well. Stick towers and lines. So you can use, again, give them challenges of making a stick that's 1 meter high or 2 meters high, and giving them sticks that are only about 20 centimeters. So they need to do a bit of DT, bit of problem solving, but also it has to be as exactly that height. Weather stations provide lots of opportunity for measuring. So we've said about thermometers and temperature, but also you've got rain gauges for calculating volume as well. So you can look at how rain volume changes over the year. And if you can collect a data source for your school, that's really, really useful resource to have. Oh, right, I've got more here. Also, orientation, orienteering. So if we think about using our map as well, so yeah, so we're looking about rotation now and fractions of turns. So if you think about the map that you've got, it provides opportunities for looking at shape as well. So you've got that background as your map, but in fact a map is just a whole load of shapes. So yeah, in foundation phase, you might be going out for a shape hunt, looking for 2D shapes and looking for 3D shapes. But when you get to the older age groups, these progression steps 3, you're looking at shapes from above, and that will link into looking at the area and calculating those irregular shapes as well. So shape hunts, yeah, as I said, go around your school grounds, trying to find all different shapes, moving on with progression steps onto 3D shapes. But I love to get them to build 3D shapes. And you've got the bottom left here, we've got cubes being built. You can use lashing for that, or there are actually connectors you can get to connect sticks together, but getting them to make sure that they've got the parameters right. So you've got the sides equal, you've got the same right amount of faces, the right amount of corners. So you've got the properties of the shape there. And I actually spent a lot of time helping make this geodesic dome, which was amazing to do. And it was brilliant to think about angles and the lengths of the sticks. They had to be exactly right. So a lot of measuring going on. So this took half a day, maybe more than that. And we had to do quite a lot of screwing and things and drilling. But I've also been with a school which they actually used kebab sticks. So they made little trapeziums. So kebab sticks, and then they tied them together with elastic bands. So each student made a trapezium, and then they lashed those together. So they put those onto elastic bands as well. And then they built that into an even bigger trapezium, and they just had this repeating pattern of more trapeziums, and they made this huge structure in the end, and it was absolutely stunning. But it really gave them that idea of that 3D shape. Also maze building, and I've said you can use maze building for algebra, but you can also use it for looking at reflective symmetry. So if you get a stick and then you do reflective symmetry, so you've got rotational symmetry, and then you rotational symmetry by 90 degrees, and then you do another one which is rotational symmetry by 180, and then you start following this stick and it starts to create this maze for you. Or you can use it to create art, like this insect on the left here. So stick insects, we're looking at reflective symmetry. This obviously has got one line of symmetry, but you could do any picture at all and then get somebody to create a reflective symmetry or rotational symmetry. So this one, you do half of it and then your partner draws makes the other half, so saying that it is a reflective symmetry. You could then also build another one, rotational symmetry of 90 degrees, and draw another one, and you get some amazing art forms. It doesn't have to be as complicated as that. It could be something quite simple, but it gets them that idea of rotational symmetry and regular symmetry as well. Angle hunts. If you look at the top here, we've got 3 angle finders there. Those are 90-degree angle finders. You can use anything. You can use your hand. That's a nice 90-degree angle finder. You can even go on Twinkle and you can cut out a picture of a hand that's doing that as well. But what you'll do, you go around your school ground and you try and find angles. So these are all 90-degree angle finders. So you're going around finding these 90 degrees. And a nice data collecting activity to do is to find 90-degree angles in your man-made structures and in your natural structures. So as you go around the man-made structures, you'll find so many more 90 degrees, whereas in the natural structures and the trees and the bushes, there's much less 90-degree angles. And some lovely investigations I like doing, and I've got a video on my YouTube channel with one of these, is looking at angles and trying to find out if there's any kind of relationship between angles. So sorting them, so you're collecting different angles and saying, right, how many obtuse angles have I got? Is there more obtuse angles than there are acute angles in the natural world, and starting to sort them by that. And you could also make pictures as well and identify the angles. So this picture on the left of this stick insect, we could also then label this with the angles. So say we use different colored bricks for different types of angles, we can put the colored bricks next to the angles that are the right ones for the color. And a nice one of doing that as well is also writing numbers or letters. And so writing 1, writing 2, and again, identifying the angles within those numbers using those colored bricks. And you could do that with anything. You do a picture, so it just gets them to start thinking about those angles. Angles are also great when you're doing den building, which of course you can then bring in your 3D shapes as well. So if you're doing den building, but you set strict parameters, it ends up being a mathematical challenge. So it's got to have a volume of such and such. It's got to be so high. It's got to have an angle of 45 degrees in the roof. It's got to be 20 meters from anybody else's. It's got to have a ground area of 2 meters squared. So den building provides a lot of mathematical challenges, and it means that you've got a focus for your den building, because it's very easy to just build a den. But if you're setting up very strict parameters, then they've got to use their math skills to actually create the den itself. Right, orienteering. Again, if you've got this map that you've got for your school ground, which is great, we could then send you around the school ground, or send your learners around the school ground using rotational language. So rotating clockwise 90 degrees, or doing a half turn to anti-clockwise. Again, if you look at the outdoor learning cards for the OEAP, they've got, it's all about orienteering, one of the sections, and there's progression from very basic, looking at map work, all the way up to orienteering. And within those, there's got one which is called cardinal cones. And I like to use that to teach rotations and fractions of turns. So you lay them out in a grid, a 3x3 grid, and then they start either in the center or one of the corners, and then you give them directions. And so you can say, right, go rotational, half a turn, anti-clockwise, and they turn that way, and then they move to the next cone, and underneath the cone there is a number or a letter, and they write that down. And then you say, right, rotational turn 90 degrees to the left, and then they move to that cone and they write that down. And then at the end they add the numbers up, and then they should give you a number, and if the number's right, then they've gone the right route. And it gives them ideas of moving rotationally. You can also, the ones on cardinal cones is actually all about using compasses, so it's north, south, east, west, but you can change that to rotation as well. Teaching coordinates, school grounds, if you can got an area, especially if you've got sand pits or something you can dig in, you can lay out a grid on it, like in this picture at the middle and the bottom, and then you can actually place things in different locations for them to dig up, or they can find places in it and then they can identify the coordinates within it. Other games you can play, things like battleships. Battleships is great. So all you need is 2 tape measures laid out, and then you need 2 packets with something, numbers on. So it could be Numicon, or it could be corks with numbers on. Pieces of paper don't work so well because of the wind. Pick out 2 numbers, that's their coordinates. One goes along the bottom, one goes along the top. They go to that coordinate, that's where their battleship is. And then another pair come and they identify the coordinates. And then if they get it right, they sink the battleship. So again, you can bring in some of your other topics as well. And then hoops, again, looking at clocks, there's not loads of ways to teach time outside, but you can use a hoop as that outside of the clock, and then sticks as the 2 hands. And even if you're sitting there and just saying, put 9 o'clock and they put the sticks in the right locations and they use chalks. But what I like to use for teaching time, when they've got the concept of time in terms of the clock itself, but thinking about time as a concept, creating something like sundials. So watching, if you've got a stick or a tree in your grounds where you can lay down something that you can get around it. So at 9 o'clock in the morning, you see where the shadow is, got to be a sunny day, and you can either paint or you can lay flour down on the line at 9 o'clock, come back in an hour, put the line down, come back in an hour, put the line down, and you can see the time there from the sundial. Or a really good challenge for your older learners is to create a water clock. So you want a container to empty in exactly a minute. So they have to consider how many holes to put in it, what angle to hold it at. And it's a lot of trial and error, but there's a lot of timing going on there. So how to make it empty in exactly a minute. And that's what matters statement 3. So that is the geometry one. Has anyone got any questions about what matters statement 3, the geometry?
Messenger video.
Sorry, say that again, Susan. Did you say something?
Nope.
No, okay, that's fine. Right, okay then, we'll go on to the last what matters statement then. So this is about statistics. This is my favorite what matters statement. So when we say statistics, we're looking about representing data. It also includes probability, models of chance, and supporting informed inferences and decisions. Now, this is our simplified version of what it covers, but realistically, we are looking at data collection, data presentation, interpreting data, looking for trends, calculating averages, explaining findings by using means, recognizing anomalies, evaluating the methods you've used to calculate, and sorting those Venn and Carroll diagrams, and also the probability. Now, if you look at this what matters statement, it covers what it covers. You can see that the data part of the statistics what matters statement 4 can be applied by undertaking any of the scientific investigations that I went through in the last session of the Science and Technology AOLE. Now, I know some of you weren't here for that session. So what I have done is I have put on this PowerPoint all of the tables for the ideas for the investigations for that you can use to teach. And so when you get this PowerPoint, you can look through them, and it's got how to differentiate it for the progression steps. So all of this is on the PowerPoint, but I'm not going to go through them. But I've included them here so that if you didn't attend the science and technology session, you can see the ideas. And it's got for each one the variables you need, the methods, the question, the equipment, and what results you expect, and also how to vary it for the 3 progression steps. So all of these investigations provide opportunities to collect data, to present the data, and different types of tables and charts. So you've got tallies and blocks, bars. It also got line graphs, pie graphs or pie charts. It also provides the opportunity to interpret the graphs, analyze the charts, to look at trends, to recognize anomalies, to calculate averages, to provide data for supporting arguments. So all of those things are covered by these science investigation. It also helps you to explain your findings and evaluate it. So they're all covered in these science investigations. However, you may want to choose an appropriate investigation to help exemplify a specific aspect of the what matters statement. So you might be teaching it or reinforcing it or testing a certain statistical concept. So what I've done here, if I've identified from those ones in the previous slides, the investigations which I think best help to package each of the mathematical skills. So if you're collecting data, if you want to make tally charts, frequency tables, probably the best investigation out of those is which habitat has the most mini beasts. That collects, really easy to collect data. Also for collecting data, but for this time for actually calculating averages, because you can't do that with the previous investigation, is if you undertake the investigation of does mini beasts with the most legs crawl the fastest. So you calculate the speed, so you're calculating that as well. And then for those that data, you repeat it, and then you work out an average from that. If you want to look for trends, the best data for that is probably looking at is the oldest child the tallest. So again, a nice line graph there that you'll create, and you can look for those trends and any anomalies as well. More line graphs, because it is difficult to collect continuous data in some places. Some schools find issues with, we do lots of bar graphs. Bar graphs, we've got them sorted. We know how to collect data for bar graphs. What about line graphs? So the person or the mini beast with the longest legs, do they jump the furthest, the highest? That gives you some nice continuous data for line graphs. So we're looking at the number of legs or the longest legs, the tallest, and then how far they jump or how high they, or how they jump, how fast they jump. If we look at different types of data, so if you want to consider how to represent qualitative data, this picture on the right is our investigation on the decomposition rate of different materials. How do you represent that in numbers? That's quite a nice conundrum for them. So obviously you can't really measure that, or can you? So thinking about how to represent qualitative data, that is actually what we do in progression step 4, really the qualitative data. So don't worry too much if you can't think of a way to do it, but you can weigh it, by the way. Evaluating your methods. So the investigation on what material will keep you warmest in space basically has got loads of errors in it, which is great, which means it's great for evaluating. So that's, you know, a really good one to look at for evaluating. Another line graph one, thinking about the effect of trampling on plant growth. So as the trampling increases, what happens to the height of the plants? And more about qualitative data, looking at how does the growth of the plant, so how is it growing? How does that affect the trampling? Now I'm going to just go through some specific maths-based investigations. So they're not scientific investigations as such, but they are maths-based investigations. And again, it will provide you with that data that you can then present, you can then analyze, and you can evaluate, you can look for trends. So it covers all of that for the data collection aspect as well. So are the tallest trees the oldest? So you need to measure the tallest trees using the trigonometry or using the many methods. You measure the circumference and you calculate the age by timesing the circumference by 2.5. You then create a line graph with the age of the tree along the x-axis at the bottom, and then the height of the tree along the y-axis, and then you do a line graph and you look and see if there's any anomalies, but also if there's any trends. Again, what's the growth rate of beans? That's the same. So you're measuring how tall the beans are, but you're doing it over time. So time always goes on the x-axis, and then the growth rate will be along the y-axis. And this is a graph you could actually grow. You could actually make this over time as it's growing. So every time you measure the growth rate, you go to the first day, you put that X in, and this is a graph you can build over time. Volumes of waters in puddles. So trying to measure the volume in a flat area of something like water is really tricky. So it's a nice, difficult thing to think about anyway, but also you're thinking about it in a 3D way. So if you've got a pond and you need to measure the area of it, and then the volume, we obviously need to go down for depth as opposed to up for height. So you're considering volume in that way as well, which is a nice twist on normal volume when we're talking about the height times the width times the breadth. So calculating the volume of water, if you've got something that you contain water in, or even if you've got puddles outside, if you're collecting up the puddle with sponges, putting them into a measuring jug, and then you can measure the volume like that. Again, sticking with your trees, you've got trees in your school grounds, especially if you don't know how old they are or you don't know anything about them, you could do an investigation to find out which is the oldest, the tallest, or the broadest. So going around measuring them all and writing this down, again, collecting a data set for your school of things like this is really useful, so you can do more data analysis later on. So if any class is collecting data on the trees in your school grounds, collect that into part of, in your T drive or somewhere, so that you can add to it, especially if you've got things like weather data, collecting that over time, and then you've got a load of data you can then and analyze and draw graphs for, which is relevant to your school grounds and your learners, but you've got it over a long time. So you can do it over years and years. So really good resource you can create there. Are leaves symmetrical? So going out, finding if some leaves are symmetrical using mirrors or just drawing and just observing. And most of them are, but there is one that isn't. So if you can find one that isn't, then that's great. So it gives them that observational skills as well. Is there a relationship between height up the tree and angle of the branches? So I've got a YouTube video on this one. So as you go up the tree, do the branches get closer, so the more acute angle to the trunk, or do they get further away? And you need a tree really where you can get as high up as you can, maybe not to the very top, but one where you can get as high up as, so that the students can still measure the height of it. And if you, the angle, sorry, if you use that angle finder that I showed you the picture of in the other slide, and if you make one that's quite easy to move, one of the pieces of wood, then what you can do is take a big protractor. So you can go measure, take that, put it on the protractor, so you actually have a number. So you're not just saying acute angles, because if you do that, that's categorical data. So you can say at the top, we've got acute angles, we've got 5 acute angles. At the bottom, we've got 7 right angles. So that's categorical data. So that's only suitable for either a pie chart or a bar graph really, because although you've got height up the tree, you've only got numbers of angles, you haven't got the actual degrees. So you need continuous data to a line graph. So continuous data along the bottom would be height up the tree and then the angle along the side. So you'd actually have a number for that. You need that for your continuous data. Okay, data presentation. So focusing specifically on how to present that data and also how to progress from basic graph creation. Students I find real difficulty in presenting data in graphs. So the way that I teach it is we do it at first as a group. So everybody together with one set of data, and we create a whole class graph of it. So I like to use either people. So we have our axes on the ground with tape measures. And then if we do a bar graph, we have each person being one of those, and they lay down and we can see the pattern, which is the longest line, which is the shortest line, and they can see it because they're lying there and they can see the person in the next line is lower down than them. So they're higher up, so their number is higher. So they get the idea that, you know, of how to lay it out, what goes on what axes. Then you send them off to do their own version with a pair, usually on the yard with chalk, but yeah, wobbly lines, and also something like blocks or something that they can use to represent the bars. And then once they've got that, they then go inside and then you say, right, now you're going to draw it. And all they need to worry about is getting a ruler to draw a straight line, because they know where the axes are, because they've done it outside twice already. They know which one goes on which. They know the rules of having gaps or not in between the bars. They know what they're expecting in terms of the shapes. So it's less formidable than saying, right, here you go, you've got your data, draw it. And also J2 Launch and all the other, you know, Excel and all that are great as a tool to know how to do a graph on a computer, but you can draw any graph in the world on Excel. It does not mean that it actually shows you anything. If you go, I moderate A-level geography coursework, and the graphs that I see, you know, categorical data put or discrete data put into line graphs, scatter graphs, donuts, and I look at it and it's like, this is absolutely meaningless. Just because the computer program will let you do it doesn't mean it's the right graph for the job. So they need to be able to understand why that is the right graph, and understanding that difference between categorical data or discrete data. So the stuff that you can't put into order, you can only put in groups, compared to continuous data where you can put it into order. So on the right top here, This is on the sand. This is categorical data. How many animals are in the lower shore, middle shore, upper shore? It's got to be a bar graph. We could do a pie chart, but realistically, this would never be a line graph unless we knew exactly where the lower shore and the middle shore and the upper shore were in terms of distance, a number. So that's a really useful thing for them to hopefully learn before they start trying to do graphs at a later date, even for science as well as maths. You can also do graphs vertically, and I love these. Like this picture here is an investigation, the science investigation. So which flowers do pollinators prefer, which color? So we've got all the colors down there, and all they do is when they see a pollinator go to that color flower, they drop a piece of Lego into that cup, and they just keep doing that. When you finish, you just clip all of the Lego together in each cup. You lie that down and you've got a vertical graph then, and you can see immediately which one is bigger and which one is smaller. So again, it really brings the idea of a graph to life, because the whole point of data presentation is that a graph makes sense of the numbers. So you're making a picture out of it. So if it's a 3D picture, it's going to be an even better one. And I don't mean a 3D graph on Excel. I mean physically seeing it going upwards. That would make more sense than actually this quite abstract concept of a line going upwards on a piece of paper, which is what a graph is. Another thing, which is I've already mentioned before, but I want to put a bit more emphasis on, is moving from this bar to line graph. So collecting those different data types, so continuous and discrete. And if you can undertake an investigation, a mathematical investigation or a science investigation, where you've got learners of different progression steps and you can actually collect data for both types, then when you come in, the learner that needs to can do a bar graph, and the learner that can or needs to be pushed can do a line graph. So you've got a bar graph for the simple ones, lines for the more complex, and things like wind speed. So collecting wind speed at different locations can be something that you do for a discrete or a continuous data set. So a discrete would be wind speed in the yard, that's the location, and then in the grass or behind the building. Turning that into continuous data, you could do wind speeds with distance from the building. So when you're on the grass, that's actually 300 meters from the building. So you write down the distance from the building as well. And then in a group or in a pair, you can both collect the same data, but when you go in, one of them will do a bar graph using just the names of the locations, and the other student that you're pushing can do a line graph with the distances as along the x-axis. Other ones you can do that is things like shadow length. So we can just say that discretely as the shadow length in behind to the north of the building, or to the south of the building, or down the bottom of the yard, or down the bottom of the field, whereas it will be shadow length distance from the thing that's making the shadow with an actual number. Plant height, again, measuring plant height, but it could be further away from a hedge or closer to a hedge, and then you can measure that distance to get that continuous data set as well. And what I like to do to explain why we do line graphs and what that information is actually telling us is do a bar graph, or get them to be a bar graph, and then the end person stays still when the others go away, and what the people that are left, that is your line graph. Right, I need to go faster, sorry. Right, hopefully that's okay with our graphs. Right, next thing, so sorting and probability, leaf logic. Everybody in the class grabs a leaf. The aim is a bit like dominoes. You need to line the leaves down. So it's the top right photo here, but you can only line the leaf, the next one down, by changing it by one characteristic. So you need to poke a big green leaf down, that's a sycamore. The next leaf can be a sycamore, but it's got to be green and it can be small. The next one can also be small, but it can be yellow. So you can only change it by one. The aim is to try and get everybody's leaf down in the whole class. And if you get to a point where you can't and you're stuck, you then need to go out and find the missing link so that you can put that down so the next person can put their leaf down. So it's great for looking for patterns as well. Sorting activities, Venn diagrams with hoops. and carol diagrams. Because of the natural variation in leaves and in an awful lot of loose parts, it's a great opportunity to start sorting things. To differentiate that, the sorting, start with 2 groups, get them to choose what they're sorting by, then extend it to 3, to 4, and then start thinking about, well, what about this one? How does that fit? It goes in 2 groups, then you bring in the Venn diagram system. But also, if you're talking about grouping, start to think about more discrete things that you are not continuous. Grouping has got to be discrete. So size, quite tricky. Is that little? Is that big? Or what about middle size? So choosing your criteria can make it more or less difficult. And building from those Carroll diagrams and that sorting, you can then start in upper key stage. So when we talk about progression step 3, start to create dichotomous keys. And if you could get your students to actually create a dichotomous key, which is the way all plants and animals are identified, for the plants in your school grounds, that's great maths, but also you end up with a resource that identifies all the plants in your school grounds that you can then use for other year groups. So this one on the bottom here, this is a dichotomous key that I've created, but how to do this, I've got a YouTube video on my YouTube channel as well, so have a look at that if you want more. And then lastly on this, I think, yes, probability, coin toss walks. So you're just walking, flip a coin, and then the direction is predicted by the coin. So if it's heads, we go right, tails, we go left, and you're just looking at where you go and where you end up. And then probability, thinking about, right, what's the probability of us finding a stag beetle in our school grounds? Very unlikely because they're very rare, but what's the possibility or probability of finding a worm, and where would we go to find it? So that is what matters statement 4. Right, hopefully you're happy with that, because I need to press on. We've only got one more left, but so reasoning challenges. These are some ideas that you can use to really embed that understanding of the application of maths. And this should help them with those reasoning questions as well in their tests. So these are some ideas for what we can do. You can ask them concepts such as repainting something. So this is a nice one. So how much would it cost to repaint the school fence? And then you provide them with as little or as much scaffolding for your students as you can. So you could add cards that you hold up or give them at the appropriate time. Things like 1 tin of paint costs £33 per litre, or you can get a tin of 750 millilitres for £25, and each tin covers, or 1000 millilitres covers 15 metres squared. So all this facts you feed into them as and when they need them, and they use that to come up with an answer. Lots of different maths from different areas coming in there. Again, how many tents can fit in your field? You tell them things like the bell tents are 5 meters in diameter, and they have 2 meters either side of guys, so they can then calculate, and they have to measure the field. Dinosaurs, there's a great dinosaur investigation which is on the Padlet, which is here, that you can set up in your school grounds some footprints, and then there is a great relationship between the size of the footprints and the size of the leg, which is 4 footprints is the size of the leg, 10 footprints is the size of the dinosaur. And you can then get them to establish which dinosaur it was. You can also establish how fast it's going. And if you're really clever, you can set up 2 sets of dinosaur footprints with the right stride length, and you can calculate, and I call it CSI dinosaur. You can see if the predator actually caught the prey by seeing which one was running fastest. So lots of dinosaur information there, which most students really love. And vegetables, I've said already about vegetables and about the challenge of the enterprise of which is most profitable. Which tree in the school grounds is the tallest? Again, this is for probably the younger ones, so they could estimate that, but then they can start to try and draw it. And which is the oldest? And then the one I really love is, if we chop down a tree, would it hit the school? So find a tree that's close enough to your school, and then they need to work out the height of it and the distance, and then looking at symmetry as well, which angle, what's the likelihood of it going in which direction. Right, so those are reasoning challenges. I hope those are clear with you. And then this is what I mentioned before with the progression skills for the tree measuring. This is on the NRW resource. So this is all on the Padlet, so have a look. Right. Is there any questions on anything to do with Maths and Numeracy AOLE? I know it's fast and furious. If you do have any questions and you don't want to say them now, you should have my email. You can do it through Eventbrite, I think, or my contact details are all on here. I'll just tell you about some resources that I've got if you are interested. I've created outdoor challenge cards for all of the AOLEs. This is the maths one, and these ones you can buy on my shop, which is naturedays.co.uk. The whole pack is £50, but you can get each AOLE for different amounts depending on the number of cards. I'm also going to be setting up a subscription service for lots of lesson plans and ideas for teaching outdoors. And the Padlet is all resources outside on the web for teaching outdoors. So please look at that. Lastly is some homework, which you can do if you feel like it and add it to your portfolio. But this hopefully will help you. And it's just about trying to integrate some outdoor learning ideas into the next Maths and Numeracy you're planning to teach in the next few weeks or the next term. Last of all, if you could feedback to me about today's session, I'd really appreciate it. If I go onto the chat box, at the top of the chat box, there is the feedback form is at the very top. So if you scroll right to the very top and click on that, then if you could fill that in, that'd be really useful. It's also got a question on it about the next session, which is on session 8, which is on language literacy and communication AOLE. It's on the 25th of January, which is a Tuesday, not a Thursday, because I got a governor's meeting, or not a Wednesday. I've got a governor's meeting on a Wednesday, so it's the day before. So please be aware that that's different to all the other sessions. If you've enjoyed today, or you would like to have anything from the other sessions, so if you'd like to buy the other sessions or you'd like to buy the whole course, then you can get 10% discount if you buy the whole course, and you will get the recording from all the last 6 sessions as well. So you will have access to the recordings and the resources from that. Right, I hope that was useful. Let me stop sharing to you, and haven't bombarded you too much. Again, if you've got Hub accounts, please do put them into the chat or send them to me so I can know where to send it. In the next couple of days, probably Friday, maybe Monday, you'll get sent the recording of this and the PowerPoint as well. So that's, sorry, we've gone over, typical. But that's it for today. I hope that's provided you with some inspiration and you feel now that you are confident to go and do some outdoor learning with maths involved. Take care. Lovely to start up again. Thank you for your lovely comments and everything, and hopefully see you in 2 weeks' time.